let's look at that example that we talked about a second ago. So we had those three vectors. We said that A1 was equal to what? 5, 0, 0, 5. We said that A2 was equal to negative 1, 0. And we said that A3 was equal to what? All fours. What does it mean for this set of vectors to be linearly dependent? From the definition. I'm not talking about the theorem, but the definition. What does it mean immediately? One of them can be defined as a linear combination of the other ones. Did we confirm that over there? Is linearly dependent since what? Since A3, and let's call it 1 times A3, was equal to 4/5 times A1 plus what? Negative 4 times A2. And then the claim that we just made is we can actually bring this over to the other side and we can say now the 0 vector, how big would the 0 vector be? 4 by 1 was now 4/5 times A1 plus negative 4 times A2 plus what? Negative 1 times A3. Could you come up with another linear combination? 8/5 times A1 plus negative 8 A2 plus negative 2 A3 also would send that to 0. We should confirm that. Should we do that as a team? All right, here we go. So 8/5 A1, what would that be? 8, 0, 0, 8 plus, what's the next one? 8, 8, 0 plus what? Negative 8, negative 8, negative 8, negative 8. What's that equal to? Okay, so now you've got this really interesting trend that the moment that I can find one vector that's non-zero, that sends it to 0, how many do I now have? Infinite number. Give me another one. Give me another set of scalars, x1, x2, x3, that would do this. And let me see if you can generate a set of scalars where, yeah, just give me another set. Give me something exotic. Because you could just multiply by 3, right? Yeah, so now you got minus 4/5 A1 plus 4A2 plus A3. And this is what I was trying to say earlier, that the negative 1 doesn't always have to exist. The moment that you found 1, my claim is you found any scalar multiple based on the concept of linearity, which we'll get to later, right? Okay. So what's the whole claim of this theorem so far? If we're trying to categorize sets of vectors as linearly dependent, the baseline definition that we're going to use in this class is what? What does that mean for a set of vectors to be linearly dependent? One of the vectors can be written as a linear combination of the other ones, which means that a set of scalars exists so that you can write that one like the other ones, but that's kind of clunky. What is the equivalent definition that we're going to use? Or the equivalent theorem that says that we can look at that in a different way? There exists a set of scalars, x1, x2, all the way down to xn, that are not all zeros, and yet when you take the linear combination, you can get to 0.